Good evening, world. I'm Irene Pease. Welcome to your Thursday evening tour around your neighborhood. I'm your friendly neighborhood astronomer coming to you out of Brooklyn. It's a great big neighborhood out there, so we're all neighbors, celestial neighbors. Tonight, I'm really excited. I have a special guest. One of my former coworkers and still kind of a partner in crime in some astronomizing that we do around New York City. So I'll be introducing him in just a moment. I do want to mention just the visuals that we have in the background. If you like those, you can check them out. Right now you're seeing Open Space, and I'll talk more about that in a little bit. You can download it for free at openspaceproject.com. And in just a moment, we'll be switching over to Stellarium, which you can find at stellarium.org. So tonight, my special guest, Brian Levine, is going to be talking to us about space debris, because apparently there's a lot of debris in space, so it's a lot to talk about. So buckle up. But first, as always, we're going to jump over to not open space. We're going to jump over to Stellarium and check out what's happening in our night skies. So here we are looking at now. This is now in Brooklyn. I'm just going to pretend this is Brooklyn because I like the skyline here. There's Mount Prospect to the south. And we can see there's some planets out, right? Jupiter and Saturn. So they're going to keep moving closer and closer. I've been talking about that. But the other fun thing that we've been talking about a bit is looking for Uranus. So I'm just going to turn on a couple of our constellation lines. Over the past few weeks, we've picked out a big square that we call the Great Square of Pegasus. And maybe you were able to pick out this kind of pentagon-shaped ringlet, the circlet of Pisces. And then last week, we were looking more at this little hook over here that's part of Aries the Ram. So as you can tell, we're kind of narrowing in on Uranus because that's kind of this exciting thing that's happening on Saturday. And so I told Brian, I gave him a heads up, he was going to have a pop quiz. So I'm just going to bring him in here and we're just going to talk about Saturday for a minute. I'm just all over the place tonight. So hi, Brian. Welcome to our weekly tour. So ladies and gentlemen,
having me.
Thank you so much for joining me. Brian Levine, ladies and gentlemen, he's the, would you say, producer and host of Astronomy on Tap NYC, which is that carries a lot. And you brought a friend with you, I see. Who's your friend?
Oh yeah, there's Jack. He's going to provide some commentary also.
Commentary from Jack. Okay, fantastic. And
it takes 8 minutes for it to get here though, so
a little lag in the commentary from Jack. Fantastic. And another fantastic thing about Brian, because like I said, we work together, we shared an office for many years, and we've done all these other events together. And one thing that Brian is known for is his themed t-shirts. And notice how he wore the most boring t-shirt of the pack for us tonight. Yeah. Thanks, Brian, for the...
It didn't quite fit on camera well, but there you go. My Mel Brooks the t-shirt.
Brooks the t-shirt. Okay. So thank you. Thank you for going all out with the t-shirt as well, Brian. So Brian, before we get to the space debris, we're doing the sky. So you know what Saturday is, right?
Halloween.
Yeah, astronomically, do you know what Saturday is?
The last day of October.
Yes, and I was hoping you might say blue moon.
I think I know. It's a blue. Yes, it's a full moon. It's a blue moon.
Yeah, it's a blue moon. And then I was going to say no, really astronomically, because blue moon is a full moon. That's astronomical. I'll give you that, definitely. So a full moon, that's, when we have this kind of syzygy, this alignment. And so we see our moon's full face all lit with sunlight. Thanks, Jack, from 8 minutes away. But the blue moon is kind of a human construct because of our calendar and months. But really the other astronomical thing is this thing that I've been trying to leaning up to, which is Uranus. Uranus is actually at opposition. So if you're not into Halloween, if you're not into blue moons, check out Uranus. So Brian, I'm going to bring you back in just a bit, but I'm going to go full screen on the Stellarium.
I'll see you all soon.
And we have Uranus in here. So again, if you're able to find those constellations, if you're able to see this hook of Aries, kind of those brighter stars up there over the last week or so, see if you can pull out some binoculars and find this little dot. I know there's a lot of little dots over there, but if you magnify it enough, you'll see one, a little bit of color. And if you have young eyes, that's even better. So, young eyes are more sensitive to color. So, all you young folk out there, while you're out voting, also go out and look at Uranus in the evening because it's fun. And also, you'll see a little bit of extension. So, if you put binoculars or definitely a telescope on it, you can tell that it's round and not just a point. So if you're able to find it in telescope or binoculars, then see if you can see it with less aids. Maybe if you can see it naked eye, this would be, in theory, a good time to look for it. The moon is going to be kind of bright and shiny over there, since, as Brian told us, it is a full moon and, in fact, a blue moon, the second full moon this month. But it's also Uranus at opposition, so the best time to try to find Uranus naked eye. So more fun things to find next week, I hope, if we're all still here and healthy and safe. But for now, I think it's time to jump on over and let Brian talk some more about space debris. So I'm going to pop back over to open space, back to the open space. And again, this is open source software that you can download for free from Open Space Project. You can basically load all kinds of data into it, fly around the universe. And I think Brian's going to be kind of taking us all over the place. So I'm going to go ahead and bring Brian back in here and kind of hand it off to him. I'll try and field some questions from the Facebook, but there's lots of windows here. So Brian, you're telling us about space debris? Take it away.
And first, just saying hi to our friend Jack here. Hi, Jack. Yep. It's probably a 16-minute. This will be over by the time the message gets back. But that's a picture of the sun from October 8th, 2014, and some active regions of the sun just happened to line up and make a spooky looking kind of Halloween face. So NASA released that a couple of years ago as a pumpkin sun, and it's just fun. So, but anyway, not what we're here to talk about, right, Jack? Nope, still no response. We are here to talk about some cosmic debris, and we're starting here on Earth, and maybe we can zoom in a little bit on the Earth, because I can't see much from out here except, well, there's a lot of blue. And that blue is, well, water. So are those clouds up in space. Lots of water. Lots and lots of water. I looked up some numbers. There are something like 300 billion gallons of water on the Earth. And annually, so that's billions of billions. It's a lot.
That's a lot of water.
That's a lot of water. A lot of gallons of water, at least. And humans use up about 7 billion of that annually just drinking, and another 150,000 gallons each per person is used up by industry. So this water, by agriculture and industry, don't worry, not making a political statement at the moment, but basically this water is used and goes through cycles. It takes about 3,000 years for a droplet of water in the ocean, for instance, to evaporate. But then on average, it gets back to the ocean in like 9 or so days. So is that debris? I don't know. That's, at least it's a cycle and it's used up. It never really changes from water to something else, but it does help shape a lot of things. Can we get some dirt on the screen here, maybe?
Is this the right dirt? I may have the wrong dirt here.
We'll get to that dirt in a minute.
Okay. Should I go to the other dirt?
We can look at that dirt anyway. I suppose we can do
dirt.
Everything.
Oh wait, is that dirt or is it soil? We were talking about this the other day.
That's true. I am calling it the wrong thing, but with a point. You hear a lot about Martian soil or moon soil on the moon. It's not soil. That's dirt. Dirt, as Irene clued me in yesterday. Dirt is dirty. But soil...
dirt's inert. That's the one thing I remember from my composting class. Dirt's inert. Thank you, BBG.
Dirt is inert. Dirt is also dirty, and is made up of rocks and minerals and things. But soil, and you can see the evidence of some soil here in the green pastures on the kind of the eastern side of the Big Island of Hawaii here. Um, Soil is made of rocks, minerals, and decaying organic matter, plus some water and some air pockets as well. Um, and there are things that are alive that help break up rocks, for instance, lichen and plants, and just weathering in general. So water and other chemical erosion can break this up. Fungi and bacteria break up that organic matter, and what you're left with is this debris. But that debris is the soil that's really rich and allows for things to grow. Earthworms have a big part in this too. I looked this one up. I know you like earthworms, Irene. Do you
They're
know one
delicious.
earthworm can digest 36 tons of soil in a year, helping to both aerate it and redistribute the elements?
36 tons?
That's
One
what the
worm.
internet
Like,
told me.
how long is this worm?
Big worm, giant worm. I don't know.
It's
That
fine.
might be, yeah. That sounded suspect, but I didn't do my due diligence. So, why are we going away from Hawaii? We wanted
Oh,
to go back to Hawaii.
we need to go back to Hawaii. Oh, yeah, because you know what's great about Hawaii? I was going to complain about this, but yeah, no daylight savings. So that whole thing that's happening later, I forgot to complain about. Yeah, good old Hawaii.
Interesting.
Let's just stay here.
Yeah, yeah. So soil is one of the, like, just the cosmic debris, dirt as well, I suppose. But soil is really, it's kind of, it's mixed. It's rotated around. It's got all sorts of stuff happening to it. It's debris that then becomes useful again. Actually saw I think a friend of mine on here, Carrie, is watching. She's big into dirt. Sorry, soil. But yeah, why'd we stop here on Hawaii though? That's
Because there's no
kind of
daylight savings.
because there's no. All right, so that's Irene's reason for stopping on Hawaii. But there's another way that Hawaii is really kind of a fascinating kind of pile of debris, because it's volcanic and it sits over a hot spot. The whole chain, if we can look at the chain for a moment, of islands has kind of slowly, the oceanic plate has slowly moved over this break in the surface underneath the water, and as molten material kind of essentially bubbles up, it solidifies the remnants of old rock and old tectonic plates, resolidifies, as in this case, a chain of islands that we know of as Hawaii. Um, yeah, there's one other kind of thing on Earth that we wanted to look at, but debris is kind of everywhere. And if we can go to New York, actually, I guess there's two things in New York we want to look at. One would be the pigeons, because everyone knows they're made of debris, right?
Debris, definitely,
Yeah.
definitely debris there.
No.
Yeah, there's no debris in New York. I've never seen 1 ounce of debris. 30, certainly not like 36, was it 36 tons? We don't have
I
any
mean,
worms here or something. I don't know what's going on.
look out on the
Which
sidewalk
borough
near
would you
my place.
like?
What's up?
Which borough would you like first?
We can head to Manhattan. I think the southern tip of Manhattan is a very interesting spot for debris. Those of you familiar with Manhattan, I assume this is a mostly New York audience, might know this story already, but basically all the dirt and excavated to dig out the original World Trade Center, as well as some of the water towers. Sorry, not water towers, water tunnels that come down to New York from upstate, so that we all have some good water to drink.
Good stuff.
Was
Makes good
was all kind of
bagels.
piled together on the southwestern end of of Manhattan, and became what is known as Battery Park City. I had a number here. Where is it? Where is it? 3 million cubic yards of material taken from various construction projects to make 92 acres of land on Manhattan. But at the very base, the very, very bottom, and maybe I'll put a little star down here because it's not moving too much, down in approximately there is South Ferry. And South Ferry was a dump site even before Battery Park was made, and has been for a long time. So there's been pieces of various coins and cannonballs, pieces of pottery and old glassware. Even an old wooden ship was recovered out. Was recovered out of the debris, basically next to and underneath South Ferry. So lots of man-made debris there, but actually had wanted to also look at another natural debris pile, which is pretty much all of Long Island. Is a giant debris pile.
Hey, Long Island, raise your hand if you live in Long Island.
Yep.
Brooklyn and Queens are on Long Island.
So Brooklyn, Queens, Nassau, out to Suffolk, did not originally exist here. It was pushed by glaciers and kind of plopped on top of a nice solid bedrock foundation. So that was good to have. But this part sticking out of the water 22,000 years ago was pushed down from much more northern regions. And you get things left over, like rocky beaches on the North Shore, which is kind of pebbles that were left under the ice. Much finer sand on the South Shore because it had much longer time where it was being pushed not under the ice, but allowed to break up much more. You've got Lake Ronkonkoma. I'm not sure I can see it from here, but that's basically just a giant glacial pothole. It had a whole bunch of ice that was just stuck there, and then when it melted and receded away, it left a giant. Actually, I think we can start to see it.
Is this it?
I was thinking this
I've
was
only
it.
been out
Nope.
to Long Island like once. I went out like
Oh no,
right
that's
here.
out in the Forks. No. I
Okay.
put a star into where I think it might be, but I'm not entirely sure.
Okay. There's a lake. There's
Um,
definitely a glacial pothole.
yes.
Oh
But I had
yeah.
wanted to mention Battery Park because when we zoom off of the Earth, we can take a look at some other human-made debris. Not all of it is, bad debris at the moment. We've got about 2,000 working satellites in what's called low Earth orbit, which is about the same orbit that the space shuttle used to go up into, and the Hubble Space Telescope is in, and the International Space Station. If you've seen Gravity, the movie, that was mostly in low Earth orbit, and it's a couple hundred miles up to about 1,200 miles up. And Irene's going to be turning on here. Oh, I think they're on actually. They're a little faint at the moment, but she's showing you kind of the relative distance above the Earth that low Earth orbit is. There we go. They're nice bright purple now. That's something like 100 brightest satellites out of the 2,000 or so that are active. There's another 20,000 objects though in that orbit, and that are like actual kind of, some of them are used up objects, some are pieces of objects, and then some are actually debris itself. And I read one estimate, and this seems almost unfathomable, that there's 128 million objects smaller than 1 centimeter. And that's like flecks of paint and screws or broken little pieces of metal or stuff like that.
It's like that time
Uh,
I chipped my nail.
exactly, yeah. Nails, they evacuate the nail clippings out the back of the space shuttle, so those are floating around somewhere. Maybe they don't. I don't think they do that. Or did that. But then there's still like a million objects, 1 to 10 centimeters in size, and 35,000 objects larger than about 10 centimeters. And then still those 20,000 or so objects that you would consider more like a macro object, I suppose. So there's a lot of debris up there, and so we have to start worrying about this. There's now a NASA Orbital Debris quarterly publication, and I just found out they had their first conference in late 2019. So people are thinking about this quite a lot.
Yeah, if
Uh,
y'all want to read a horror story about that, I think it's called the Kessler effect. So Google that after this, not now, but later.
or watch Gravity, and we can yell at the screen together about things that are just wrong in that movie. All right, so let's move out a little bit. I only have a couple minutes left here, don't I? Let's move not from our own debris and junk, but to the stuff left over from the formation of the planets and basically our solar system. Now, really, as we zoom out, you can see the orbits of some of these planets here. Really, all of the planets themselves you could consider kind of debris. They're left over from the formation of the sun. The sun is the major component. It takes up over 99.9, if I remember percent correctly, of the mass of the solar system. So all the other stuff is just in tiny, tiny percentage. But the planets, I don't know if we'd consider them debris. They do some pretty significant things. They yeah, they do stuff. They have atmospheres, et cetera, et cetera. We know some stuff about planets, but
They have worms crawling around inside of them, producing lots and lots of aerated soil.
yep, yep. And if you are a Dune fan, they might have giant worms as well. Um,
Those are called MTA trains.
yes, they do kind of look like MTA trains that have grown off of their tracks. Let's look at, thank you, yeah, some asteroids here. These are the Trojans, or the asteroids that are in orbit around the sun. Well, they're all in orbit around the sun. But these ones kind of either follow or trail Jupiter. And Jupiter is right about here. Yep, there's my little star, and Irene was pointing to it also. They exist. These exist at points where the gravity from the sun and Jupiter kind of balance out. They're called Lagrange points. Faisal just pasted something in about the Kessler effect into the chat, in fact. And oh, Carrie does have a lot of soil love to give. But anyway, so this is just one kind of group of asteroids that kind of leads and follows Jupiter. There are many, many more. So Irene just turned on, what are these ones called again?
This
The
is
outer
the
belt?
outer main belt. The main belt will break this, like everything will crash.
So
So, and
we'll
actually, I'm
try
just
not
gonna
to crash it.
pause because it's trying to crash. No crashing. Okay.
Okay, yeah, it was getting a little jerky in my vision here, but yeah, there are a lot of these objects. If you can show us flat view of the solar system, that would be great, because you do still find a lot of these in the plane of the solar system, along with the rest of the planets and things. There we go. Now they're small. They're relatively small compared to the planets, so they can get kicked around into different orbits. But everything kind of started in this nice flat orbit, and that's kind of evidenced by by many of the things that we find. Asteroids are generally kind of rockier or metal. They are leftover chunks of things that really kind of didn't become the building blocks of planets. So they represent what was the building blocks of planets, and kind of never got used up. Can we turn on some comets, Irene?
Yeah, there's our Encke comets.
So comets are generally they have more volatiles, so things like ices. I'm not seeing much of them right now.
They're kind of
We
faint.
might
They're
need
like
to
a
zoom
deep
in, yeah.
purple. Yeah.
And they're a
So
little
have a
bit
look.
closer. So if I think I couldn't find much a description of the Encke set of comets, but what I was deducing is they're kind of short period comets, stable, kind of mostly in the plane of the solar system as well. Oh, sorry, we had a question from Leo here. Are they affected by? You probably mean the Trojans that we had up a minute ago. They are kind of pulled along the orbit with Jupiter. Yes, so they're in pretty stable locations, in fact. But back to the comets.
Do you want to see the other
These
set?
ones. What's up?
Did you want to see the other set?
Yeah, in a second. So
Okay.
these ones are very flat, but and they're relatively close in. Yeah, I wasn't too sure about what else makes this set a specific set. So let's go to the Halley type comets, because those can get very much out of the plane. They have much longer orbits. Um, can we make those any brighter by chance?
Mm.
And well, Irene might work on that. But basically, they have like 20 to 200 year orbits. They go out into the space between Saturn and Neptune. And because they're out there kind of among the gas giants in between them, they can actually get perturbed pretty easily. and take these paths that kind of go up and over and under the solar system as opposed to just in the plane. And comets are there. We go. Comets are small. They're icy. They're rocky, as I was saying earlier, and so they're it's not too hard to like kind of capture and kick them out into other orbits. Asteroids as well, but the sets of asteroids we looked at weren't as far out and were in nice stable orbits. So you do find asteroids out here as well in all sorts of crazy orbits around that have been kicked out too. And as we keep zooming outward, were we going to turn on some Kuiper Belt objects, I think?
Yeah. Let's have a real party, because those comets aren't fun enough. Comets are pretty fun, but this is the other system that tries to break, but it usually doesn't actually break.
Oh, oh.
Okay.
Slowing down. There we go. Yeah. So
there.
lots and lots of comets out here. I forgot to throw some estimates out there, but it's something like 1 to 2 million asteroids and comets that are at least a half-mile wide or in diameter. There are millions, if not billions, of smaller ones. Part of the reason I wore this shirt too was just a reference back to all those sci-fi instances where you're flying through the solar system and you have to avoid all the asteroids and comets and things like that. Even though we're throwing out huge numbers like this, that is entirely unrealistic, because the solar system is big, basically. So there's not really they're not really as close as you might think they are. But anyway.
I think there's a question. How could they break the solar system's gravity plane so wildly if they're so small?
They aren't doing it themselves. It's the interactions with the gravity of Jupiter and of Neptune and what's after Neptune? Uranus.
Opposition Saturday.
Yeah. So kind of weaving between them. If you're not exactly flat, you might come on a little bit angled to one of them, and then it just kind of pulls you in a direction, pulling down or up or whatever. And if you do that a couple of times, you wind up out there, and it happens again. Maybe in 12 orbits, it happens again, and it just winds up kind of kicking it out of the orbit. When you get near to the gas giants, if you're not captured by it, which is also a possibility, then things can go a little haywire. Anyway, so Kuiper Belt objects, it's another kind of batch of essentially comet-like material that's out there, but there's some larger objects. Pluto and is considered one of these Kuiper Belt objects as well. If you've heard of Eris, also another big object out there, that is a Kuiper Belt object indeed. And out here, so the end of the solar system and I did a show on this before about where is the end of the solar system, and there are kind of several boundaries, if you will, but this is really the last one. If you go out a little more than a light year and a half out from the sun, you get to this giant wire frame. It's not actually there. Hey, we're outside of it. This represents something like a light year and a half out from the sun in radius, so about 3 light years across, 2.5 to 3 light years across, if I'm remembering correctly. And what this is the kind of the very last spot that any gravity from the sun is really holding on to any significant number of objects. And scientists believe, there are trillions of tiny objects out here. And these are in kind of a cloudy, kind of spherical shape. And it's called the Oort cloud, named, who it's named after, I mean?
Mr. Cloud.
Mr. Cloud, of course.
I've taught with Brian before. He and Jack tell really great jokes.
Thank you. Jack's just really late to the joke telling.
8 minutes. Give him 8 minutes.
Yeah. Jan Oort, I believe was his name, kind of theorized that this is out here, and is just kind of the last stuff that was kind of slowly, it was able to drift away from the sun, but it was still held on to by gravity, by the gravitation of the sun. We've seen some comets very long period comets that can be kind of, if you trace back, if you like turn back time and figure that you can trace back their orbit, they probably came from out this far. They can take millions of years to orbit the sun. And the reason we don't know if they're really there, we haven't observed them in place, is because the sun is so dim out there, and then that reflection would have to get back to us that it's just too dim to see. So we don't have observational evidence that they're out there directly, but we have evidenced some objects kind of falling in, and it makes sense that there's kind of this outer kind of layer that is just the last things being held on. So we'll get back into our own solar system in a couple of minutes, but let's move out a little bit. I want to visit, Irene, I want to visit some planetary nebula.
Okay.
So maybe we could start with the Ring Nebula, and while you're looking for that, I'll talk a little bit about what that means. Stars like our own sun do not go supernova. They don't explode. They kind of slowly run out of hydrogen, burning into helium, which is the main power horse inside of the star. And once that happens, there's a couple of different processes. Some of the insides shrink down a little bit. The outside kind of starts blowing up a little bit, but not blowing up like explosion, blowing up like just getting bigger and bigger. And what you'll have is a red giant phase of the sun, of a star. In our own sun, the red giant phase will maybe just about envelope Earth. It'll definitely, though, kind of swell up and swallow up the orbits of both Mercury and Venus. But then those outer layers continue to kind of drift off over a period of roughly 10,000 years. We've seen a couple thousand of these in our own solar system out of about 200 billion stars. So by estimate, and knowing that time scale, there's somewhere between about 3 and 20,000 that probably exist at any time in our own solar system. How are we doing on the Ring Nebula here? There, we're starting to zoom in. Wonderful. So the Ring Nebula, one of the more famous ones, very colorful, beautiful nebula. And in this case, a nebula is any kind of gaseous cloud, essentially, that is being lit up either from heat from a source in the middle or from shock waves that are heating the material together. But the Ring Nebula is it's about 2,500 light years away, which is maybe why Irene's having trouble finding it. We could just pop up the picture if you wanted.
I don't mind the lost astronomer.
We do have a pic. Yeah, there we go. There's kind of that official NASA Hubble picture of it, which looks better than anyway. But yeah, it's about 2.5 light years in diameter. It's very spherically symmetric from a single star in the middle that is a red dwarf. Red giant, kind of ending its red giant phase, becoming a white dwarf. Very, very hot in there. These can be hundreds of times kind of more luminous, or in total more bright than the sun, but they're much smaller too. So it's like a tiny little really bright LED next to a kind of a bigger light bulb, for instance. The blue and green is ionized oxygen. The red is mostly hydrogen with some nitrogen in it, and it's been expanding for something like 1,600 years. And this outer shell will just continue to expand and is essentially becoming debris, and will enter the interstellar medium and can be used in kind of the next rounds of star formation, perhaps. But it's not going to trigger star formation. We'll get to that in a few minutes. You want to take a peek at the Dumbo Nebula, or should we move on?
I can definitely find that one.
All right.
It's here. I got it.
It was right near I remember the two were quite near each
Yeah,
other. She's much more the observational astronomer than I.
Oh.
There it is.
Easy peasy, like you do.
Yep. And the Dumbo Nebula is a fairly large one. It was the first planetary nebula found. I did not write down when, but it was the first planetary nebula found. It's been expanding for about 10 to 15,000 years, but only about 1,200. Oh, sorry, it's about 1,200 light years away. It's not much bigger than the Ring Nebula, though, for expanding that long. There are different expansion rates for these, so it's only about 3 light years in diameter, even though it's been expanding 4 or 5 times as long. Whoop,
Oh,
we
I
seem
forgot
to
about that part.
have. There's also a single star there, but it's had a lot longer to kind of create some structure in the gases around it. Not an expert on what all those little knots and dark spot patches mean, but they are very interpretable. And I think Irene's going to bring up, yeah, there's kind of that nice Hubble image of it as well. Um, yeah, and these will just kind of, so you've got two different debris in here. You've got the outer layers of kind of what was formed inside of the star slowly kind of being cast off, and you've got that white dwarf in the middle, which is hot and kind of a big ball of hot carbon, if you will, mostly. But this is not the only way a star can die. And so in a galaxy like ours, there should be, on average, about one supernova every 100 years. The last one that we know of that was observed in our own galaxy, though, I think was this one, which went off almost 1,000 years ago in the year 1054. So these are just averages based on stellar populations and seeing other galaxies. It's also possible one went off and was so obscured by dust, maybe on the other side of the galaxy, that we couldn't see it. Although they get pretty bright, they can outshine entire galaxies, and that is really, that's a core collapse and implosion, explosion. All the horrible things that you know about supernova are probably not even nearly half of how violent the explosion is that happens. Um, but they're not as what's left over is this nebula again, and this is the Crab Nebula left over from the supernova in 1054, as I mentioned, that was recorded by the Chinese most famously, but also many other cultures. There's some cave paintings in the Southwest in the U.S. that may refer to it. Seems to be in the right location in the right time period.
And you couldn't miss it. I mean, it's like it was visible during the day, right? It's just
Oh God, yeah. I
like
looked it up. It was, the estimates are between a magnitude of -4.5 to -7, so absolutely brighter than Venus, and it was visible, and it should have been visible in the daytime for at least 2 years. So this isn't something that you could have missed because you slept through one night. This was there and slowly faded away. Its diameter is about 11 light years, and remember, it's only been 1,000 years, so it's expanding at about 1,500 kilometers a second, which is about a 0.5% of the speed of light. Um, and what? Whoop! Hey there. Yeah, we got multiple nebula. uh, what you get in a supernova, though, is an immense amount of energy and much more mass than in a star that becomes a planetary nebula, being cast off much faster. It can create shock waves. It has new elements in it that are not creatable in any way other than either supernova or like black hole collisions. So it's seeding the universe with all sorts of lovely new stuff. We'll get back to why that's important in a minute, but we see them all over the place. So the most recent nearby one did not happen in our own galaxy. It happened in one of our satellite galaxies, the Large Magellanic Cloud, back in 1987. There was a famous astronomical paper written right before then that kind of predicted what you would see in a supernova in terms of its spectra and in terms of what the light curve should be also of this type of supernova. And then lo and behold, one was seen it was like 2 or 3 years later. I don't remember the date of the publication, but it was nicely coincident. This one peaked at magnitude 3, but correct me if I'm wrong, the Large Magellanic Cloud, Irene, is only really visible in the southern hemisphere, or
yeah,
equatorial
it's
at least.
you have to be pretty far south. I'm not sure if you can see it from Hawaii. Someone wants to ring in on that. Yeah, pretty
So
far
here in the,
south.
even if you were alive in New York City in 1987, you would not have seen it. Um, but it was it was still pretty bright. It was brighter than a lot of stars that are part of constellations, not the brightest ones, not like Sirius or Aldebaran or something, but it was still bright enough to be seen easily and noticed. And what we've been able to do, and what Irene pulled up here, is we've been able to watch as the shock wave moves out and heats up the surrounding material around it that had already kind of been cast off in its red giant phase. And over time, we can watch as that changes and develops and learn a lot about how the supernova shockwave moves through the medium around it. Again, this is allowing the universe to kind of be seeded with extra material. So where does that material go? It goes in lots of places, and it can start new stars forming. So Irene, I think let's bring it back to our own solar system, because the implications from supernova reach very locally. For those out there keeping track, by the way, the Large Magellanic Cloud, or the supernova 1987A, whichever way you want to think about it, something like 168,000 light years away. But still the closest supernova to have gone off since the invention of the telescope, back in the late 1500s, early 1600s. So why did we come back to the solar system? Because, as I kind of mentioned earlier, planets are a form of debris, if you will. They're the leftover stuff from the formation of the sun. But if you were just forming the sun in the very, very first early universe, not first, but the very first moments of stellar formation in the universe, you only had hydrogen and helium to work with until you started to have some supernovae. So you didn't have planets that had rocks and metals on them. I don't know if you would have had hydrogen and helium planets. I guess that's possible. But also, a lot of those stars were rather huge and went supernova pretty quick. So even if you did have planets, or you might not have even had time to form them. But the point is, after several generations of supernovae, we have enough silicon and iron and carbon and nitrogen and oxygen and gold and platinum and all the bling in the universe, basically, to create large planets and to provide all the elements needed for life. So in a very big way, we ourselves and everything on the Earth are cosmic debris as well. And so, yeah, it's a big kind of recycling bucket here in the universe.
That always makes me feel so good. Like, even if we don't recycle, you know what? The universe recycles. Like on the grand scale, big picture, people, big picture. I remember what else Saturday is, so I'm not going to keep complaining about daylight shifting and all that bogusness. But the other thing that's on Saturday is, if people have been listening for a few weeks, I've been going on and on about this. Um, as of this Saturday, October 31st, there will have been people living continuously in space for 20 years. So that's also kind of
Oh, that's
awesome.
cool.
So there's that ISS. Wave to the space people on the space station. Yes, you can vote from space. If you haven't voted, go vote. Even the astronaut in the space station voted. So no excuses, folks. Um,
Yes.
so
Faisal's chiming in the chat that we're not just star stuff, we are also debris, so are the astronauts.
all good
Um,
stuff. Debris
yeah.
doesn't, it's not a bad thing. It's not a bad
No,
thing at all.
no, we need debris. We need it to live. We need it to walk on.
Yeah.
Um, yeah. Shout out
So
also to Rosemary and Greg, who said hello in the chat. Hey, everyone.
yeah. So thank you so much, Brian, for joining me and guest hosting here. In addition to all your astronomy, it's nice to see that you're drinking. I'm just drinking water tonight, but normally we're both drinking at
I got
Astronomy
some
on Tap
scotch.
events. So people check out the Astronomy on Tap events. We're gonna go ahead and sign off for this evening. I'm just gonna put my credits up here. So
Little plug
again,
too. There's a bio on tap
if
New
you
York City going on right now too.
so if you're interested, if you like the visuals again that you saw in the background, go ahead and check those out. Stellarium at stellarium.org and OpenSpace at openspaceproject.com. Again, I'm Irene Pease, your friendly neighborhood astronomer. Thank you so much for joining me and my guest Brian for just a little stroll around our great big celestial neighborhood. And we just want to wish you clear skies, be safe, and wear a mask.